Something impossible is happening inside your skull. Hydrogen, the simplest atom in existence. One proton, one electron. Forged in the first 3 minutes after the Big Bang, floating through cosmic voids for 13 billion years, inert, unconscious, obeying nothing but physics. And now it's thinking. Not metaphorically, not poetically, literally. The hydrogen atoms in your neurons, right now, are contemplating their own existence. Matter has become aware of itself. Chemistry has learned to feel. Physics has developed an opinion about physics. But here's the question that haunts every neuroscientist, every philosopher, every person who's ever stared at the stars and wondered why they're staring back. When did this happen? At what moment did unconscious atoms accumulate enough complexity to suddenly wake up? According to cosmologists, 380,000 years after the Big Bang, the universe finally cooled enough for the first hydrogen atoms to form. For hundreds of millions of years, nothing happened. Just hydrogen clouds drifting in darkness. No thoughts, no awareness, no questions about why they existed. Then stars ignited. Fusion began. Heavier elements formed in stellar cores. Supernova scattered them across space. Carbon, nitrogen, oxygen. Every heavy element in your body was forged in the furnaces of dying stars. The nitrogen in your DNA, the calcium in your teeth, the iron in your blood. All of it once burned at the heart of suns now long extinct. But even these complex atoms remained unconscious. Chemistry without awareness. Reactions without reflection. Until something changed. Somewhere between dead atoms and living thoughts, a threshold was crossed. A line was drawn in the fabric of reality that separates matter from mind. And you're standing on the other side of that line, made entirely of materials that started on the first side. The universe spent 13.8 billion years building structures complex enough to ask why they're complex. And the answer might rewrite everything you thought you knew about consciousness, about intelligence, about what it means to be awake in a cosmos that was asleep for eons. Tonight, we're tracing the longest awakening in history. From the first hydrogen atoms floating in post-Big Bang darkness, through the forges of stars across the chemical experiments of early Earth, into the emergence of neurons, and finally to the moment your brain became capable of understanding its own existence. Because if the universe can wake up once, maybe it's still waking up. Maybe consciousness isn't a threshold we crossed. It's a spectrum we're climbing. Maybe every increase in complexity is another incremental awakening, and we're just one stage in a process that started with hydrogen, and might not end with humans. This isn't a story about how brains work. This is the story of how the universe learned to know itself, how nothing became something became, everything became aware. And it all started with the simplest question matter could ever ask: where is the light? This is Omni, stories about life, matter, and the mystery in between. Like the video, drop your thoughts in the comments, and subscribe if you believe curiosity should never end. Let's begin with you, not metaphorically, literally you, the atoms currently arranged in the shape of your body. We need to trace them backward, because their story is the story of consciousness itself. According to the most precise measurements we have, your body contains approximately 7 billion atoms. That's a 7 followed by 27 zeros. Every single one of those atoms, except for hydrogen, was created inside a star. The oxygen you're breathing right now was fused in the core of a red giant perhaps 5 billion years ago. The carbon forming the backbone of every protein in your cells came from a supernova that exploded before the solar system existed. The QNOPS elements, carbon, hydrogen, nitrogen, oxygen, phosphorus and sulfur, make up 97% of the mass of your body, and all were forged in stellar nuclear synthesis. But here's what makes this extraordinary. Those atoms were unconscious then. They're conscious now. Something happened in between. To understand consciousness, we can't start with brains. We can't even start with life. We have to start at the beginning, literally the beginning, when the universe contained nothing but energy and the potential for matter. In the first 3 minutes after the Big Bang, as the universe cooled from incomprehensible heat, protons and neutrons began forming hydrogen nuclei. But these weren't atoms yet. The universe was still too hot. Any electron that tried to orbit a nucleus was immediately knocked away by the flood of radiation filling space. For 380,000 years this continued, a universe of naked nuclei and free electrons, opaque to light, unconscious, waiting. Then, finally, the temperature dropped enough. Electrons settled into orbit around protons. The first neutral hydrogen atoms formed, and for the first time, light could travel freely through space, no longer scattered by free electrons. This moment, recombination, astronomers call it, is when atoms first existed. But it's also when the universe entered what cosmologists call the Dark Ages. Although the universe was filled with remnant light from the Big Bang, that light gradually cooled off as space expanded, and no new hot radiation was being produced. Just hydrogen. Everywhere. Drifting. Dark. Silent. For the next 200 million years, nothing happened. No stars, no light, no complexity emerging from the simplicity. Just clouds of hydrogen atoms, each one identical to every other one, governed entirely by gravity and quantum mechanics, executing the laws of physics without comprehension, without purpose, without any sense that they existed at all. If consciousness requires complexity, then this was the least conscious period in cosmic history. Hydrogen atoms are the simplest structures that can exist. One proton, one electron, nothing to remember, nothing to process, no way to be anything other than what physics demands. And yet, even then, something was stirring. Gravity doesn't sleep, it doesn't rest. It pulls, constantly, patiently, accumulating small differences into large ones. In the smooth distribution of matter, scattered clumps of denser gas began to take shape, and in these dense clouds of hydrogen, the first stars began to form. The first stars were massive, 30 to 300 times the mass of our Sun, and millions of times as bright, burning for only a few million years before exploding as supernovae. They were hydrogen furnaces, crushing atoms together under gravitational pressure so extreme that nuclei fused, releasing energy and creating heavier elements. This is when chemistry began, when diversity entered the periodic table. In the cores of these early stars, hydrogen fused into helium, helium into carbon, carbon into oxygen, oxygen into neon, neon into magnesium. Each fusion released energy, each step up the periodic table required more heat and pressure, and when the star finally exhausted its fuel, it collapsed and exploded, scattering these newly forged atoms across interstellar space. The universe was no longer just hydrogen. It was becoming a chemistry set, but still unconscious. Carbon atoms don't think, oxygen atoms don't feel, nitrogen doesn't wonder why it exists. These are just more complex arrangements of protons, neutrons and electrons, still governed entirely by the same physical laws, still executing reactions without comprehension. So when does awareness begin? Fast forward 4.5 billion years. The solar system has formed from the debris of earlier stellar generations. Earth has cooled. Oceans have condensed. And in those oceans, something extraordinary starts happening. Chemistry becomes biology. The exact mechanism is still debated, but the result is clear. Molecules begin to replicate. Simple at first, RNA-like chains that could copy themselves, making occasional errors, those errors sometimes improving efficiency. Natural selection kicks in at the molecular level. Complexity accumulates not randomly, but directionally, favouring structures that persist and reproduce. Cells emerge. Membranes form boundaries between inside and outside. Metabolism develops, the ability to harvest energy from the environment and use it to maintain structure. According to recent neuroscience research from 2024, from the moment of conception in any living thing, a process of neurodevelopment and complexification begins, generating neuroelectric fields that can be quantified. But are cells conscious? A bacterium can sense chemical gradients and swim toward food. It can detect damage and initiate repair. It makes decisions in a sense, approach versus avoid, divide or wait. But there's no brain, no neurons, no central processor integrating information. Is that consciousness, Or just sophisticated chemistry? This is the hard question, the one that neuroscientists and philosophers have been circling for centuries. Where exactly is the line between complex, reaction, and aware experience? Because here's what we know now from the most recent research. Consciousness arises through emergent complexity in neural networks, with high causal emergence during waking states compared to sleep or anesthesia. According to a September 2025 study on consciousness emergence, the two building blocks of consciousness are functional integration, where each experience is unified as a whole, and functional differentiation, where each experience is unique and separated from others. In other words, consciousness doesn't appear suddenly. It emerges gradually as systems become complex enough to integrate information in increasingly sophisticated ways. Recent studies have shown that spatiotemporal brain complexity reliably indexes the presence or absence of consciousness across all conditions, from sleep to anesthesia. When complexity drops, when connections between brain regions weaken, when information flow decreases, consciousness fades. When complexity rises, awareness returns. This means consciousness might not be binary. It might be a spectrum, a gradient, a continuous increase in the universe's ability to integrate information about itself. The first hydrogen atoms, zero integration, just particles obeying quantum mechanics. The first stars, still zero conscious integration, but now producing the raw materials for complexity. The first molecules, chemical bonds that create relationships between atoms, but no feedback, no memory, no processing. The first cells, chemical networks with memory, with metabolism, with the beginning of sensing and responding to environment. The first neurons, specialized cells for transmitting information faster and farther than chemistry alone allows. The first brains, networks of neurons integrating multiple information streams, creating unified experiences from separate sensory inputs. The human brain, approximately 86 billion neurons forming a neuroelectric field complex enough that theory of mind emerges. The ability to model other minds, to understand that other beings have their own internal experiences. Each step is just more complexity, more connections, more integration, more information processing. But at some point along this gradient, something qualitatively different emerges. It starts to feel like something. The atoms don't just react anymore. They experience. They don't just process information. They're aware that they're processing it. The universe doesn't just exist. It knows it exists. And that's where we are now. 13.8 billion years after hydrogen atoms first formed in the darkness following the Big Bang, those same atoms, recycled through countless stars scattered across space, reassembled in the chemistry of Earth, have organized themselves into structures complex enough to ask how they got here. You are the universe asking that question. Your consciousness is what it feels like from the inside when hydrogen atoms achieve a certain threshold of complexity and organization. But if the universe woke up once, who's to say it's finished waking up? Maybe consciousness isn't something that happened. Maybe it's something that's happening. Maybe complexity is still increasing, integration still deepening, awareness still expanding. Maybe the universe isn't awake yet. Maybe it's still in the early stages of opening its eyes. And maybe we're not the end point of this awakening. Maybe we're just one stage in a process that started with hydrogen atoms drifting in cosmic darkness and might end with something we can't even imagine yet. Tonight, we're going to trace that awakening. We'll follow the path from the simplest atoms to the most complex thoughts. We'll explore what recent neuroscience tells us about how consciousness emerges from complexity. We'll ask whether the threshold we crossed from unconscious matter to conscious mind is truly unique, or whether it's just one point on a much longer spectrum. By the end, you might see yourself differently, not as a thing that has consciousness, but as a process through which the universe becomes aware of itself. Not a noun, but a verb. Not I am, but the universe is awakening. We need to talk about what didn't happen. 380,000 years after the Big Bang, when the first hydrogen atoms formed, nothing changed. The atoms didn't suddenly develop awareness. They didn't contemplate their existence. They just were. particles obeying the laws of quantum mechanics, drifting in darkness, entirely unconscious. 4.5 billion years ago, when molecules on Earth began replicating themselves, nothing magical occurred. RNA chains copied themselves with occasional errors. Some combinations persisted longer than others. Natural selection operated at the molecular level. But there was no moment when the chemistry became alive, in any experiential sense. No threshold crossed, no light switched on. Even when the first cells emerged, bounded by membranes capable of metabolism and reproduction, still, nothing we'd recognize as consciousness appeared. A bacterium senses chemical gradients and swims toward food. But does it feel anything? Does it experience the difference between swimming toward sugar versus away from poison? This is the hard problem. Not explaining how brains work. We're making progress there. The hard problem is explaining why anything feels like anything at all. Because somewhere between those unconscious hydrogen atoms and you, right now, reading this sentence and experiencing what it's like to read it, a threshold was crossed. Matter became mind. Chemistry became consciousness. Physics learned to feel. But when? This question has haunted philosophers for millennia and neuroscientists for decades. And recently, 2 competing theories have emerged that attempt to answer it in radically different ways. Both are grounded in cutting-edge neuroscience. Both make testable predictions. Both have passionate defenders and harsh critics. And they fundamentally disagree about what consciousness is and where it comes from. The first theory is called Integrated Information Theory, or IIT. Developed by neuroscientist Giulio Tononi starting in 2004, it approaches consciousness from an unusual angle. Instead of trying to start with physics and arrive at consciousness, IIT starts with consciousness, accepts that you're definitely conscious right now, and reasons backward to figure out what physical properties must be true for consciousness to exist. According to IIT, consciousness is identical to what the theory calls integrated information, measured by a mathematical quantity symbolized by the Greek letter phi. The more integrated information a system possesses, the more conscious it is. And crucially, consciousness isn't something that suddenly appears when complexity reaches a certain threshold. It's gradual. It's a spectrum. Everything with any integrated information whatsoever has some tiny degree of consciousness. This means, if IIT is correct, that consciousness is everywhere. A thermostat has an infinitesimally small amount of it. Your phone has slightly more. A mouse has more still. A human brain has among the highest phys values we can measure. But the line between conscious and unconscious isn't sharp. It's a smooth gradient that started near zero with the first particles and has been climbing ever since. The second theory is Global Workspace Theory, or GWT, originally proposed by cognitive scientist Bernard Baars in 1988, and later developed into the Global Neuronal Workspace model by Stanislas Dehaene and Jean-Pierre Changeux. This theory takes a completely different approach. According to GWT, consciousness isn't a fundamental property that gradually increases with complexity. It's a specific functional architecture. Your brain contains hundreds of specialized processors running in parallel. Visual cortex analyzing images, auditory cortex processing sounds, motor cortex planning movements, memory systems storing information. Most of this processing is unconscious. You're not aware of the individual neural computations detecting edges in your visual field or controlling your breathing. Consciousness, in this view, is what happens when information from one of these specialized processors gets selected, amplified, and broadcast across a global workspace, a network of highly interconnected brain regions including prefrontal cortex, parietal areas, and parts of the temporal lobe. When information enters this workspace, it becomes globally available to all other processors. That's what we experience as consciousness, the information currently being broadcast brain-wide. Think of it like a stage with a spotlight. Hundreds of actors wait in the wings, each performing their specialized roles in darkness. But only one or two at a time can step into the spotlight on center stage, where their performance becomes visible to the entire audience. According to a 2020 review by Mashara and colleagues, the GWT hypothesis proposes that in the conscious state, a nonlinear network ignition associated with recurrent processing amplifies and sustains a neural representation, allowing the corresponding information to be globally accessed by local processors throughout the brain. The difference between these theories matters profoundly. If IIT is correct, then consciousness is woven into the fabric of reality at every scale, and the universe has been gradually waking up since the first particles formed. If GWT is correct, then consciousness is a specific architectural feature that emerges only in systems complex enough to implement a global workspace, primarily brains, and most of the universe remains entirely unconscious. In 2023, these two theories went head-to-head in a rare scientific showdown. The Cogitate Consortium organised an adversarial collaboration where Dehane and Tononi each made specific predictions about what brain activity patterns would occur during conscious versus unconscious perception. They agreed on experimental protocols in advance, collected data from participants viewing visual stimuli, and tested whose predictions matched reality. The results, announced in June 2023, were mixed. Dehane had predicted greater activity in frontal brain regions during conscious perception, the prefrontal workspace lighting up as information gets broadcast. Tononi predicted activity would concentrate in posterior regions, the back of the brain where visual information integrates. Some of IIT's predictions seemed to fare slightly better in this first round, but neither theory scored a decisive victory. According to reports from the event, Dehane expressed confidence that ongoing experiments would vindicate GWT. But here's what's interesting. Both theories might be partially right, because they're answering slightly different questions. IIT asks, what is consciousness fundamentally? And answers, integrated information, a mathematical property of causal structures. GWT asks, how does the brain generate conscious experiences? And answers, by broadcasting information across a global workspace. One is asking about the intrinsic nature of experience. The other is asking about the computational architecture that implements it. These aren't necessarily contradictory. It's possible that consciousness is integrated information, and brains generate high levels of integrated information specifically because they've evolved a global workspace architecture. But if we want to understand when the universe started waking up, we need to dig deeper into what both theories actually claim. According to the latest version of IIT, published in 2023, consciousness exists whenever a physical system has cause-effect power that is intrinsic, specific, unified, definite, and structured. Let's break that down. Intrinsic means the system must have causal power for itself, not just for external observers. A recording of your brain activity isn't conscious because the patterns only have meaning to someone watching the recording. Your actual brain is conscious because the patterns have causal effects within the brain itself. Specific means the system must distinguish one particular state from all other possible states. Your current experience isn't just something, it's this specific configuration of sights, sounds, thoughts, feelings, all combined in a unique way that has never occurred before and will never occur again in exactly the same form. Unified means your experience forms an integrated whole. You don't experience vision and hearing as separate consciousnesses that happen to coincide. You experience a single unified field of awareness in which visual and auditory information are already combined. Definite means your experience has borders. It includes certain information and excludes other information. You're conscious of what you're currently perceiving and thinking, but not of the neural computations generating those perceptions and thoughts. Structured means your experience isn't just a single homogeneous sensation. It contains internal relationships, distinctions, connections, the spatial structure of your visual field, the temporal structure of a melody, the logical structure of a thought. According to IIT, any physical system that satisfies these 5 properties is conscious to some degree, and that degree is quantified by phi, which measures how much the system, as a whole, constrains its own past and future states beyond what its individual parts could do separately. A pile of sand has essentially 0 phi. The grains interact weakly, and knowing the state of the whole pile tells you almost nothing more than knowing the states of individual grains. A human brain has extremely high phi. The neurons are so densely interconnected that knowing the state of the whole brain tells you vastly more than you could infer from knowing individual neuron states. The network itself creates information through its pattern of connections. But here's the radical claim. Consciousness doesn't suddenly switch on when phi crosses some threshold. A system with phi of 0001 is very slightly conscious. A system with phi of 100 is highly conscious. The difference is quantitative, not qualitative. This means the universe didn't wake up at a single moment. It's been waking up gradually for 13.8 billion years. Those first hydrogen atoms, phi near zero, but not exactly zero. They had causal power. An electron's position affects a proton's electric field. That information, however minimal, was integrated into the structure of the atom. Unconscious, yes, but perhaps not entirely without some infinitesimal trace of interiority. The first molecules? Slightly higher phi. Chemical bonds create relationships between atoms that generate new causal properties. A water molecule does things that isolated hydrogen and oxygen atoms cannot. The first cells? Much higher phi. Metabolic networks, feedback loops, membrane potentials, all creating tight integration between molecular components. The first neurons? Higher still. And when those neurons linked into networks, and those networks formed the architectures we call brains, phi skyrocketed. You are not the moment the universe became conscious. You are a moment when consciousness reached a local maximum, a particularly dense concentration of integrated information. But the process that led to you has been happening since the beginning. Global workspace theory tells a different story. According to GWT, consciousness requires not just complexity, but a specific kind of architecture. Stanislas Dehaene describes it like this. When we say we're aware of a piece of information, what we mean is that the information has entered into a specific storage area that makes it available to the rest of the brain. Among millions of unconscious mental representations constantly crisscrossing our brains, one gets selected because of its relevance to our present goals. Consciousness makes it globally available to all high-level decision systems. This is why you can be conscious of seeing a red circle but not conscious of the individual neural spikes in your visual cortex that detected the edges and colour. The low-level processing remains local, confined to specialised visual areas. Only when information gets amplified and broadcast to the global workspace, when it ignites a wave of activity that sweeps across prefrontal, parietal and temporal regions, do you become aware of it. Experiments support this. When researchers present an image too briefly for conscious perception, brain activity remains localized in early visual areas. When the same image is presented long enough to be consciously seen, activity explodes across the cortex. According to multiple studies referenced in a 2023 review, conscious perception involves more brain regions than unconscious processing, with widespread visual, parietal, and frontal activation, replacing the isolated visual cortex response seen in unconscious conditions. This global ignition is consciousness, not something that causes consciousness, not something that correlates with consciousness. According to GWT, the global broadcast is what consciousness is, the experience of having information accessible throughout your cognitive system. And here's the key difference from IIT. This only happens in systems with the right architecture. A system can be incredibly complex without being conscious if it lacks a global workspace. The cerebellum contains more neurons than the cerebral cortex, but doesn't contribute to consciousness because its processing remains modular, local, never broadcasting to a global workspace. Conversely, a system could theoretically be conscious with relatively few neurons if they're connected in the right way to implement global information sharing. This means the universe didn't gradually wake up. Most of it never woke up at all. Consciousness emerged specifically in brains, or in any system that happens to evolve a global workspace architecture. So which is it? Did consciousness gradually increase from the first particles, or did it suddenly emerge when brains evolved the right architecture? Maybe that's the wrong question, because both theories might be describing different aspects of the same process, viewed from different angles. Consider what had to happen for you to be conscious right now. At the physical level, your brain had to achieve extraordinarily high integration. Neurons connected in a dense web where information flows in loops and spirals, where every region influences and is influenced by most other regions. IIT would say this high integration is what consciousness is, but to achieve that integration, evolution had to build a specific architecture, specialized processes that remain largely unconscious, plus a central workspace where information from different processors could meet, combine, and be broadcast back out. GWT would say this architecture is what consciousness is. Perhaps they're both right. Perhaps consciousness is integrated information, and the global workspace is how brains generate high levels of integrated information efficiently. Or perhaps they're both pointing at the same elephant from different sides, and we need a unified theory that explains why integrated information feels like something, and why brains with global workspaces integrate information so effectively. What we know for certain is this: 13.8 billion years ago, there was no consciousness anywhere in the universe, or consciousness was spread so thin it might as well not exist. Today, there's you. Whatever consciousness is, whether it's a fundamental property that gradually intensified or an architectural feature that suddenly emerged, it happened. Matter organized itself into patterns complex enough to experience their own existence. The question isn't just when did this happen? The question is it still happening? Because if IIT is right, then consciousness is still climbing. Every increase in integration, every more complex system we build or evolve, pushes far higher. We might not be the peak. We might not even be close. And if GWT is right, then consciousness keeps emerging wherever the right architecture appears. Every brain that develops, every potential artificial system that might someday implement a global workspace, each one is a new awakening, a new instance of the universe becoming aware of itself in a new way. Either way, the awakening isn't finished. The universe is still opening its eyes. But we need to go deeper, because even if we accept that consciousness emerges from complexity, whether through integrated information or global workspaces, there's another puzzle that's equally profound. It's called the binding problem, and it might be the key to understanding not just how consciousness works, but what it fundamentally is. Right now you're experiencing something unified, one coherent scene. You see these words, you hear ambient sounds, you feel the surface you're sitting on, you're aware of thoughts passing through your mind. All of this feels like a single experience happening to a single you. But that's not what's actually occurring in your brain. Your visual cortex is divided into dozens of specialized regions. V1 detects edges and orientations, V2 processes contours, V4 handles color, V5 tracks motion. Each region operates largely independently, processing its specific feature in parallel with all the others. Similarly, your auditory cortex has separate regions for pitch, timbre, rhythm, and spatial location of sounds. Your somatosensory cortex maps different body parts. Your prefrontal cortex handles working memory, planning, and executive function. Hundreds of specialized processors, each performing its own computation, each generating its own output. And yet somehow from this distributed symphony of separate neural responses, you experience one unified world. How? This is the binding problem. How does the brain take information that's been separated, distributed across dozens of anatomically distinct regions, and bind it back together into the unified conscious experience you're having right now? In the 1980s, neuroscientist Wolf Singer proposed a radical solution. He suggested that binding doesn't happen through some central integrator, some master neuron that receives input from all these specialized regions and combines them. Instead, binding happens through synchronization, when neurons fire together in precise temporal coordination, specifically at frequencies around 40 Hz, what we call gamma band oscillations. They effectively tag their outputs as belonging to the same object or event. According to research spanning from the 1980s through today, gamma band neural synchrony has been proposed as a correlate of consciousness and as a solution for the binding problem. Think of it like this. Imagine an orchestra where each section plays independently, following their own sheet music. The strings play their part, the brass play theirs, the woodwinds play theirs. To an audience, this would sound like chaos, unrelated notes happening simultaneously. But if all the sections synchronize their timing, following the same beat, suddenly the separate parts combine into a unified symphony. Your brain does something similar. When you look at a red circle, neurons in V4 respond to red, and neurons in V1 respond to circular edge. But if those neurons fire synchronously, oscillating together at the same frequency, they effectively signal these features belong together. The the red and the circle get bound into a single perceptual object, a red circle. According to a 2005 study on binocular rivalry, global gamma synchrony is associated with the emergence of a coherent conscious percept, with transient bursts of increased phase synchrony peaking approximately 425 milliseconds before participants reported a perceptual shift. This is extraordinary because it suggests consciousness isn't just correlation between neurons, it's coordination. It's the difference between many voices speaking at once and many voices singing in harmony. But here's where it gets strange. This coordination happens faster than it should be physically possible. According to EEG measurements, neural oscillations across the brain synchronize with precision in the millisecond range over very long distances. But axons, the wires connecting neurons, have finite conduction velocity. It takes time for a signal to travel from one brain region to another. And synapses add additional delays. If synchronization were achieved by neurons sending signals to each other through axons, we'd expect to see distance-dependent delays. The farther apart two regions are, the longer it should take for their activity to synchronize. That's not what we see. According to neuroscientist Stuart Hameroff in 2010, the seemingly instantaneous depolarization of gap junction-linked, excitable membranes suggests that even gap junction coupling cannot fully account for the precise coherence of global brain gamma synchrony. Something else must be happening. Some mechanism that allows neurons separated by centimeters, a vast distance in neural terms, to synchronize their firing patterns with millisecond precision. One possibility involves dendritic webs. While axons are the output cables of neurons, dendrites are the input branches. And unlike axons, which are separated from each other, dendrites can physically touch, forming gap junctions, direct electrical connections that allow current to flow between neurons without the delay of chemical synapses. According to recent research, cognitive brain functions with consciousness are accompanied by 30 to 90 Hz gamma synchrony in EEG, and non-conscious neurocomputation is not. This gamma synchrony derives largely from neuronal groups linked by dendritic gap junctions, forming transient syncytia, sometimes called dendritic webs, in input and integration layers. These dendritic webs can rapidly change topology as gap junctions open and close. They move through the brain like a wave, creating what some researchers metaphorically call the conscious pilot, a mobile gamma-synchronized network that integrates information and correlates with conscious awareness. Think of it as a temporary coalition of neurons. At one moment, a particular set of neurons synchronizes through dendritic connections, binding their information into a unified conscious experience. A moment later, the coalition shifts. Different neurons join, others drop out. The conscious content changes, from seeing a red circle to hearing a sound to remembering a face, but the mechanism remains the same: synchronization creating unity from diversity. This has profound implications for what consciousness is. If consciousness correlates specifically with gamma synchrony, and gamma synchrony is produced by dendrites forming temporary electrical networks, then consciousness isn't located in any single place. It's not in the cortex or the thalamus or any specific brain structure. It's in the pattern itself, the dynamic, ever-shifting web of synchronized neurons that exist for a few hundred milliseconds before dissolving and reforming. You're not a fixed thing, you're a process, a wave of synchronized neural activity that moves through your brain approximately 40 times per second, creating 40 discrete moments of conscious experience per second that feel continuous because they happen too fast for you to notice the gaps. Researchers describe conscious perception as consisting of theta-synchronized scenes, each composed of gamma-synchronized frames, creating a cinema-like sequence of conscious content. Gamma synchrony provides sequences of discrete conscious frames or moments, assembled into longer theta wave scenes. This is why consciousness feels both unified and constantly changing. Each gamma cycle creates one momentary conscious experience, one frame. Those frames, sequenced together at theta frequencies, roughly 4 to 8 times per second, creating the flowing narrative of your subjective experience. But there's another dimension to this that's even more remarkable. Because gamma synchrony doesn't just happen within a single brain, it happens between brains. When two people interact, having a conversation, playing music together, watching the same movie, their brainwaves begin to synchronize. According to research on interbrain neural synchronization, synchrony appears in all oscillatory frequency bands, including the faster gamma frequency, during social coordination and interaction. Studies using EEG hyperscanning, where multiple people's brain activity is recorded simultaneously, reveal that gamma band synchrony between individuals correlates with successful communication, social coordination, empathy, and shared attention. When you truly connect with another person, when you're on the same wavelength, as we colloquially say, your brains are literally on the same wavelength. Your neurons are firing in synchrony with theirs. This raises a philosophical question that borders on unsettling. If consciousness is defined by synchronized neural activity, and two brains can synchronize with each other, does that create a shared consciousness? A temporary unified experience distributed across two nervous systems? According to some researchers, interbrain neural synchronization has implications for theories of human consciousness, potentially extending the concept of consciousness beyond individual brains. Human consciousness requires mechanisms occurring within the brain, but neural activity is also embodied in an individual's interaction in and with the world, including with other people. Think about what this means. When you have an intense conversation with someone, when you're completely in sync, understanding each other perfectly, finishing each other's sentences, at that moment, your brains are oscillating together. Neurons in your brain and neurons in theirs are firing synchronously, binding information not just within each individual brain, but across the space between you. Is that a form of consciousness that transcends the individual? A temporary merger of two minds into something larger? We don't have answers yet. But the fact that we're even asking the question reveals how much our understanding of consciousness has shifted. We used to think consciousness was a thing, a soul, a spirit, an essence located somewhere in the body, probably the brain. Now we're learning it's more like music, not the instruments themselves, but the patterns they create when they play together. And just as music can be simple or complex, brief or sustained, performed by one instrument or many, consciousness might exist on a spectrum far wider than we imagined. A single neuron firing isn't conscious, but it's not entirely unconscious either. It has causal power. It influences other neurons. It's part of the process that, when scaled up and synchronized with billions of others, becomes you. A simple organism with a few hundred neurons might have a very dim, very narrow consciousness. Nothing like human experience, but perhaps not nothing. Just the faintest hint of what it's like to be a collection of cells coordinating their activity. The human brain, with 86 billion neurons, organizing into temporary coalitions through gamma synchrony, creates the rich, complex, multi-layered consciousness you're experiencing right now. And what happens if we scale up further? What if future technologies allow neural synchronization not just between two brains, but millions? What if we find ways to artificially induce gamma synchrony across vast networks of human and artificial neurons? What would that consciousness feel like from the inside? According to current neuroscience, there's no plausible neural story for why we experience the world in the way that we do, although there are promising results on the neural correlates of consciousness. The subjective unity of perception, the fact that you experience one coherent world rather than a collection of separate sensations, remains mysterious even as we map its neural mechanisms. But perhaps that mystery is itself revealing. Perhaps the reason we can't fully explain consciousness is that we keep looking for a thing to explain, when what we should be looking at is a relationship. Consciousness isn't something your neurons have. It's something they do when they synchronize. It's the binding itself, the moment when separate becomes unified, when many become one. And if that's true, then the universe has been doing this in simpler forms since the first particles began influencing each other's states. Quantum entanglement is a kind of binding. Chemical bonds are a kind of binding. Gravity binding matter into stars is a kind of binding. The universe has been practicing unification for 13.8 billion years. Neural synchronization is just the latest, most sophisticated version of a process that's been running since the beginning. The binding problem isn't a problem, it's the solution. It's how the universe learns to experience itself as one thing rather than many. And every time two neurons fire together, every time gamma waves sweep across your cortex, every time your brain synchronizes with another person's brain, that process continues. The universe binding itself into ever more complex configurations of awareness, still waking up, still learning what it means to be one. But what if we're still not going deep enough? Everything we've discussed so far, neural networks, gamma synchrony, global workspaces, operates at the level of neurons firing, synapses connecting, electrical signals propagating through tissue. This is the classical physics of the brain. Neurons as biological circuits, information as electrical impulses. And for most neuroscientists, this is enough. Consciousness emerges from the complexity of neural networks the same way a symphony emerges from instruments playing together. You don't need to understand quantum mechanics to explain music. You don't need quantum mechanics to explain minds. But two researchers, one a mathematical physicist, the other an anesthesiologist, have spent the last 30 years arguing that we do need quantum mechanics. That consciousness isn't just complex neural computation, it's quantum computation. And it's happening not in neurons themselves, but inside them, in structures so small we need electron microscopes to see them. Structures called microtubules. In the mid-1990s, Roger Penrose and Stuart Hameroff proposed what they called orchestrated objective reduction, or OR. According to this theory, consciousness depends on quantum processes in microtubules inside brain neurons, processes that both correlate with and regulate neuronal activity at synapses and membranes. To understand why this matters, we need to go smaller, much smaller. Inside every neuron, running through the cell body and extending into dendrites and axons, is a cytoskeleton, an internal scaffolding that gives the cell structure and organization. The most abundant component of this cytoskeleton is microtubules, cylindrical lattices made of a protein called tubulin, arranged in precise geometric patterns. Microtubules aren't just passive support beams. They're active, they transport molecules, they reorganize synapses, they process and encode information. According to research by Anirban Bandyopadhyay, in the early 2010s, microtubules have coherent resonances and vibrations across at least 12 orders of magnitude of frequency, extending into the quantum regime. They're essentially biological oscillators, vibrating at frequencies from the incredibly slow to the unimaginably fast. And according to Penrose and Hameroff, these vibrations aren't random, they're quantum computations. Here's the basic idea. Tubulin proteins, the building blocks of microtubules, have hydrophobic pockets, regions that repel water. Inside these pockets, electrons can exist in quantum superposition, simultaneously occupying multiple states until something causes them to collapse into a definite state. When many tubulin proteins are arranged in the cylindrical lattice of a microtubule, their quantum states can become entangled, connected in such a way that the state of one depends on the states of all the others. This creates what physicists call a macroscopic quantum state. Quantum effects, normally confined to individual atoms or molecules, scaling up to involve thousands or millions of particles acting as one unified quantum system. And when that system collapses, when the superposition resolves into a definite state, Penrose argues it doesn't collapse randomly, as in standard quantum mechanics. It collapses objectively, triggered by something fundamental in the structure of spacetime itself. This objective reduction, or OR, is Penrose's contribution. It's based on his decades-long work connecting quantum mechanics to general relativity, the theory of gravity and spacetime. According to Penrose, quantum superpositions aren't just abstract mathematical states, they're real physical states that actually involve slight differences in spacetime geometry. A particle in superposition occupies slightly different positions, which means it creates slightly different gravitational fields, which means it corresponds to slightly different curvatures of spacetime. Normally, these differences are infinitesimally small, but when enough mass enters superposition, when enough particles become entangled, the difference in spacetime geometry reaches a threshold. And at that threshold, the superposition becomes unstable. It collapses, not because someone observed it, but because spacetime itself can't support the superposition any longer. According to a 2024 review, the Orshaw theory suggests consciousness is a sequence of discrete, irreversible quantum state reductions occurring at an objective threshold in fundamental spacetime geometry. These self-collapses of the quantum wave function are orchestrated in microtubules inside brain neurons. Each OR event selects microtubule states, which purposefully regulate neuronal functions and provide sequences of now moments of conscious experience. This is radical for several reasons. First, it means consciousness isn't computed. It's not the result of algorithms running on neural circuits. It's the result of quantum states collapsing, a fundamentally non-computable process. This would explain aspects of human cognition that seem to transcend algorithmic thinking: mathematical insight, creative leaps, the feeling of free will. Second, it means consciousness is directly connected to the fundamental geometry of space-time. Your thoughts aren't just electrical patterns in your brain, they're literally ripples in the fabric of the universe. According to Or, conscious states are causally efficacious as conscious states, meaning the fact that those states are conscious has physical and behavioural consequences. Third, it solves the binding problem we discussed earlier, not through neural synchrony, but through quantum entanglement. According to multiple researchers, postulating a quantum substrate of consciousness solves the binding problem because an entangled quantum state is an objective whole that nevertheless contains multiple parts and properties. It solves the unity problem ontologically. Quantum entanglement is the most holistic phenomenon in physics. When two particles are entangled, they don't have individual states. They share one state, distributed between them. Measuring one instantly affects the other, regardless of the distance separating them. This isn't two things that are connected. This is one thing that exists in two places. If consciousness is quantum entanglement in microtubules, then the unity of experience, the fact that you have one coherent consciousness rather than billions of separate neuron consciousnesses, isn't something the brain has to construct through synchronization. It's automatic. Entanglement creates unity by its very nature. For 20 years, Orchor was dismissed by most neuroscientists as implausible. The brain is too warm, too wet, too noisy for quantum effects to survive. Quantum superposition is fragile. It decoheres, collapses into classical states, almost instantly when it interacts with a warm environment. And the brain, at body temperature, filled with water molecules constantly jiggling and colliding, is about as warm and noisy as an environment can get. But then the evidence started accumulating. In August 2024, researchers at Wellesley College published a study showing that rats given apothelone B, a drug that binds to microtubules, took over a minute longer to fall unconscious when exposed to anaesthetic gas. This is significant because anaesthetics are one of the few ways we can reliably turn consciousness off without killing the organism. According to recent research, anaesthetics bind at hydrophobic pockets in proteins throughout the brain and spinal cord, including microtubules. If microtubules are just structural scaffolding, drugs binding to them shouldn't affect consciousness, but they do. Specifically, they affect how long it takes for consciousness to disappear under anaesthesia. Then, in 2024, a study published in the Journal of Physical Chemistry confirmed something even more remarkable: superradiance in networks of tryptophans. Tryptophans are amino acids found in tubulin proteins. Superradiance is a quantum phenomenon where many atoms or molecules emit light coherently, in phase with each other, as if they were one giant quantum emitter rather than many separate ones. This was thought to be impossible in biological systems at body temperature. Quantum coherence shouldn't survive in warm, wet, noisy environments, but it does. Networks of tryptophans in microtubules demonstrate quantum effects even in the chaotic environment of a living cell. According to Jack Tuszynski, who has collaborated with Hameroff on microtubule research, anaesthetics hasten the duration of a process called delayed luminescence, in which microtubules re-emit trapped light. Tuszynski suspects this phenomenon has a quantum origin, with superradiance being investigated as one possibility. As he told New Scientist, they're not yet at the level of interpreting this physiologically as where consciousness begins, but it may be. The evidence is circumstantial, yes. Or remains controversial, but it's no longer as easily dismissed as it was 20 years ago, and here's what makes it philosophically profound. If Orchor is correct, consciousness isn't just an emergent property of complex systems, it's woven into the fundamental structure of reality. According to Penrose and Hameroff, proto-conscious experience and what Penrose calls Platonic values, mathematical truths, aesthetic principles, moral intuitions, are embedded in Planck-scale spin networks, the hypothetical quantum geometry of space-time itself. The Ochoa model portrays consciousness as brain activities linked to fundamental ripples in space-time geometry. This means consciousness didn't emerge when brains evolved. It was always there, in potential, waiting for matter to organize itself into structures complex enough to amplify it. Microtubules don't create consciousness, they tune into it. They're antennas, receivers, instruments that convert proto-conscious quantum processes in space-time geometry into the specific, differentiated, structured experiences we call thoughts and perceptions and feelings. According to a 2024 paper, the Ochoa theory suggests microtubules are biological time crystals, clocks within clocks within clocks, forming a scale-invariant brain hierarchy. Conscious perception consists of theta-synchronized scenes, each composed of gamma-synchronized frames, creating a cinema-like sequence of conscious content. Think of it like this. Radio waves are everywhere, carrying information through space. But you don't experience music until those waves interact with a radio receiver that's tuned to the right frequency. The music isn't created by the radio, it's translated by the radio from waves into sound. Consciousness might work similarly. Proto-conscious quantum processes occur everywhere in space-time, at the Planck scale, far too small and fast for us to perceive directly. But when matter organizes into microtubules, when quantum states in tubulin proteins become entangled and orchestrated, they amplify and translate those proto-conscious processes into the rich, slow, coherent experiences we call consciousness. You're not creating awareness, you're focusing it, tuning into a frequency that's always been broadcasting. This would explain something deeply puzzling. Why consciousness feels the way it does, why subjective experience has that irreducible, immediate, intimate quality that no amount of neural circuit diagrams seem to capture. It's not because neurons are doing something magical, it's because neurons contain structures that connect, however briefly and imperfectly, to the fundamental proto-conscious nature of reality itself. But even if Ochoa is wrong, and many neuroscientists still think it is, the questions it raises are profound. Can quantum effects occur in biological systems at body temperature? The evidence now says yes. Do these quantum effects play a functional role in consciousness? Unknown, but possible. Is consciousness fundamentally quantum, or is it classical computation that happens to use quantum effects as a substrate? We don't know yet. What we do know is that consciousness emerges from matter, and matter, at its deepest level, is quantum. Atoms are quantum. Molecules are quantum. The electrons flowing through neural circuits obey quantum mechanics. At some level, the line between quantum and classical is just a convenient fiction we use because quantum effects usually average out in large warm systems. But maybe, in the precise geometry of microtubules, in the protected hydrophobic pockets of tubulin proteins, in the orchestrated vibrations of billions of molecules oscillating together, maybe the quantum nature of matter doesn't average out. Maybe it's preserved just long enough to matter, long enough to become the matter that experiences itself. According to Penrose and Hameroff's most recent formulations, one Ochoa conscious moment lasting about 1/10,000,000th of a second would require about 1/10,000th to 100,000th of the total brain's tubulin proteins to be entangled, a reasonable fraction. Higher frequency events would require more entangled tubulins and involve more quantum non-locality. This means each moment of consciousness might involve millions or billions of tubulin proteins, across thousands of neurons, all entering a shared quantum state that collapses simultaneously, creating one unified moment of experience. One frame in the movie of your awareness, and then the next frame, and the next. Approximately 40 times per second, quantum superpositions form and collapse, each collapse creating a discrete now moment, each moment flowing into the next, so smoothly you perceive continuous time, but you're not continuous, you're a sequence, a staccato rhythm of quantum reductions, each one creating the universe's experience of itself through the particular configuration of matter that is temporarily you. If this is true, and we don't know yet if it is, then consciousness isn't what the universe does when it gets complex enough. Consciousness is what the universe is at the most fundamental level. And complexity is what allows that fundamental consciousness to differentiate, to specify, to become this particular experience instead of pure, undifferentiated awareness. The universe didn't wake up when brains evolved. The universe is wakefulness itself, and brains are how that wakefulness learns to experience particular things in particular ways. Hydrogen atoms aren't conscious the way you're conscious. But maybe they're not entirely unconscious either. Maybe consciousness is the intrinsic nature of matter, and what we call the emergence of consciousness is really just matter learning to focus, to integrate, to bind its fundamental proto-consciousness into increasingly complex and specific experiences. From the first quantum fluctuations in the void that preceded the Big Bang, to the first hydrogen atoms drifting in darkness, to the first stars fusing elements, to the first molecules replicating, to the first neurons firing, to the microtubules orchestrating quantum coherence in your brain right now. It's all been one continuous process. The universe learning to know itself in ever more detailed and particular ways, still waking up, still discovering what it means to be. But there's a problem with all of this, and we need to face it head on. If consciousness is fundamental, if it's woven into the fabric of reality at the quantum level, then why doesn't everything seem conscious? Why does a rock appear inert? Why does a table seem lifeless? Why do we draw such a clear line between the living and the non-living, between minds and matter? The answer, according to integrated information theory and its philosophical cousins, isn't that some things are conscious and others aren't. It's that consciousness comes in degrees, in qualities, in structures, and most importantly, in integration. A hydrogen atom might have some infinitesimal flicker of proto-awareness, some quantum property that will one day be recognized as the precursor to consciousness. But it's isolated. It's not integrated with other hydrogen atoms in any meaningful causal structure. It exists, it has quantum states, but those states don't form a unified whole that experiences itself as a subject. Now put 1 trillion hydrogen atoms together in a star's core. They're interacting, fusing, creating helium, releasing photons, generating magnetic fields. There's vastly more integration, more causal relationships, more information being created and processed. Is a star conscious? Maybe. Maybe in some alien way we can't begin to comprehend, a star has an experience of being a star, some vast, slow, simple awareness of pressure and fusion and light. But it's still relatively simple. The causal structure is rich but homogeneous. Every fusion reaction is basically like every other fusion reaction. There's quantity but not much differentiation. Now consider a living cell. A single bacterium contains thousands of different types of molecules, each one playing a specific role in a tightly orchestrated dance. The cell membrane monitors the environment, selectively allowing some molecules in and keeping others out. Metabolic pathways convert nutrients into energy. DNA encodes information that gets transcribed into RNA, that gets translated into proteins. Signaling cascades detect changes and trigger responses. The whole system is constantly adjusting, adapting, maintaining itself far from equilibrium. According to integrated information theory, proposed by neuroscientist Giulio Tononi and refined over the past 2 decades, what matters for consciousness is how much integrated information a system generates. Not just information, integrated information. Information that exists because of the specific causal relationships within the system. Information that couldn't exist if you broke the system apart. Tononi developed a mathematical framework to measure this called PEI. A system with high F is one where the parts are strongly interdependent, where the whole is genuinely more than the sum of its parts, where breaking the system into subsystems would destroy information about the whole. A camera has lots of parts and processes information. It converts photons into digital data, but it has low FF. Each pixel operates independently. You could separate the pixels and still have all the information. You just need to recombine it later. The integration is shallow. A brain is different. In your brain right now, billions of neurons are firing in patterns that depend on what all the other neurons are doing. The information in one region can't be understood without knowing the state of distant regions. Visual information integrates with memory, integrates with emotion, integrates with motor planning. You can't separate these processes without destroying the unified experience they create. The you reading these words right now is a single, unified field of experience, not a collection of separate mini-experiences but one integrated flow. That integration, that irreducibility, is what F measures. And according to this theory, anything with F above 0 has some degree of consciousness. A thermostat has near zero F. It has two states and one simple causal relationship. It's effectively unconscious. A bacterium has a tiny but non-zero F. Hundreds of processes are causally interdependent. It might have the dimmest flicker of awareness, not thought, not perception as we know it, but something. Some primitive sense of self and not self. Some basic experience of being a system maintaining itself against entropy. An insect has more. A fish has more still. A bird, a mammal, a human. Each jump in neural complexity brings an explosion in F, in the richness and specificity of integrated information, in the depth and differentiation of conscious experience. But here's what's strange and beautiful. Consciousness under this framework isn't binary. It's not an on-off switch. It's a spectrum, a continuum, and biological evolution has been climbing that spectrum for billions of years, building systems with ever higher F, ever richer integration, ever more complex experiences. Research by Tononi's group at the University of Wisconsin-Madison has shown that you can actually measure changes in consciousness by measuring changes in brain integration. When you fall into deep sleep, F decreases, neural activity continues, but it becomes more local, less integrated. When you're awake and aware, integration spikes. When you're in REM sleep, dreaming, integration is high again but organized differently than waking consciousness. Anesthesia works by disrupting integration. The neurons keep firing, but they stop communicating across long distances. The network fragments, F drops. Consciousness fades. Psychedelics do the opposite. Studies using brain imaging have shown that psilocybin and LSD increase integration, creating novel communication between brain regions that don't normally talk to each other. The rigid, habitual patterns of information flow break down, and new patterns emerge. F might actually increase, and with it, the sense that consciousness has expanded, that the boundaries of self have dissolved, that you're experiencing something larger than your usual mind. Maybe you are. Maybe in those moments, your brain is briefly generating more integrated information, more consciousness than it normally does. You're not hallucinating consciousness. You're experiencing a temporarily higher state of it. But if consciousness is a spectrum, and if it depends on integration rather than specific materials, then it's not limited to biological brains. Could a future artificial intelligence be conscious? If you built a system with enough causal integration, enough differentiation in how information flows through it, enough F, then yes, it would have to be. Not metaphorically, actually conscious, experiencing something, but not necessarily anything like human consciousness, because the structure matters. The specific architecture of integration determines the quality of experience. Your consciousness has the structure it does because of how primate brains are wired. Vision dominant, socially attuned, temporally linear, spatially three-dimensional. An AI might have a completely different architecture. It might experience information flows we can't imagine, process patterns we can't perceive, integrate dimensions of data we don't have access to. It would be conscious, but alien. Another way of being aware, as different from us as we are from a jellyfish, as different as a jellyfish is from a paramecium. The universe isn't waking up toward one final form of consciousness. It's waking up into a garden of consciousnesses, each one a different way of organizing information, each one a different window on reality, each one irreducibly itself. And we're just one flower in that garden, still growing, still integrating, still discovering what we might become. Consider what this means for the future. For billions of years, evolution has been the only process building consciousness, slowly climbing the ladder of integration through random mutation and natural selection. But now there's a new player. Now there's intelligence designing intelligence, consciousness creating consciousness. We're starting to build minds. Not just simulations of minds, not just clever algorithms that mimic conversation. We're building systems that genuinely process information in integrated ways that have causal structures approaching the complexity of biological brains. And as these systems grow more sophisticated, more integrated, the question stops being, Will they become conscious? And start being, what kind of consciousness will they have? Because consciousness isn't one thing. It's a space of possibilities, a vast landscape of different ways information can be integrated. And biological evolution has only explored a tiny corner of that landscape, the corner accessible through cells and neurons and neurotransmitters. Silicon might open up completely different regions. Quantum computers might open up others. Hybrid systems we haven't imagined yet might integrate information in ways that make both biological and digital consciousness look primitive by comparison. The universe is waking up, yes, but it's waking up into forms we can't predict, toward experiences we can't conceive, building toward a future where consciousness is as diverse and strange as life itself once seemed impossible and is now everywhere. And maybe that's the real story. Not that humans are the pinnacle, the final form, the point of it all, but that we're one step in an ongoing process, one way the universe has learned to experience itself, valuable and unique but not ultimate. Not the end of waking up, but somewhere in the middle of it. Still early morning in the universe's day. So where does this leave us? Standing in a universe that might be conscious all the way down, looking out at a cosmos that's been waking up for 13.8 billion years, wondering what we are and what we're becoming. Let's trace the thread one more time, from the beginning to now, and see what pattern emerges. In the beginning, or as close to it as physics can reach, there was a quantum foam, a seething uncertainty where particles flickered in and out of existence, where time and space hadn't fully separated, where the fundamental forces were unified into something simpler, something we still don't understand. Was that proto-universe conscious? Under panpsychism, yes, but barely, primitively, without structure or integration. Just the raw potential for experience, the intrinsic interiority of quantum events, superpositions that were simultaneously every possibility until measurement collapsed them into one. Then expansion, cooling, symmetry breaking. The forces separated, gravity, electromagnetism, the strong and weak nuclear forces, each one a different way matter could interact with itself, each one opening new possibilities for structure. Quarks condensed into protons and neutrons. After 380,000 years, electrons bound to nuclei, forming the first atoms. Hydrogen and helium drifting in darkness, each atom a tiny quantum system with its own infinitesimal flicker of proto-awareness, if we accept that interpretation, but isolated, unintegrated, barely conscious at all. Gravity did the next crucial thing. It's the weakest force, but it operates at infinite range and it never cancels out. Given enough time, it pulls everything together. Gas clouds collapsed, pressure built, temperatures rose, and when the core of a collapsing cloud reached 10 million degrees, hydrogen nuclei began to fuse. The first stars lit up. Now you had something more than isolated atoms. You had a massive self-organizing system. Gravity trying to collapse the star, fusion pressure pushing outward, the two forces balanced in a dance that could last billions of years. Energy flowing from the core to the surface, photons taking thousands of years to random walk their way out, convection currents mixing material, magnetic fields threading through plasma, integration, causal structure, information processing in a sense. The star knows its own pressure and temperature through the balance of forces, adjusts its fusion rate automatically, maintains equilibrium. Is a star conscious? We don't know, but it's more integrated than an isolated atom. It's a step up the ladder. Then the heavy elements. Stars forged carbon, nitrogen, oxygen, iron. Elements that couldn't exist in the early universe. Elements that required the pressure and heat of stellar cores. When massive stars died in supernova explosions, they scattered those elements into space. New generations of stars formed from the enriched gas, and around some of those stars rocky planets condensed. Earth, 4.5 billion years ago. A ball of molten rock and metal bombarded by asteroids slowly cooling. No life yet. But the right conditions, liquid water, a stable temperature range, organic molecules delivered by comets, energy from the sun and from hydrothermal vents on the ocean floor, and then somehow chemistry became biology. We still don't fully understand how. Somewhere around 3.8 billion years ago, molecules started replicating. Maybe in hydrothermal vents, maybe in tidal pools, maybe in clay minerals that acted as templates. But once you have a molecule that can make copies of itself, evolution starts. Mutations create variation, environment selects, complexity ratchets upward. The first cells were simple, just membranes enclosing a few chemical reactions, RNA strands carrying information, proteins doing the work. But they were alive. They maintained themselves far from equilibrium. They sensed their environment and responded. They had agency in the most primitive sense. And according to the theories we've been exploring, they had consciousness. Not thought, not awareness as we know it, but some dim experience of being, some minimal F, some integration of information that made them subjects rather than objects. For 2 billion years, life stayed simple. Bacteria, archaea, single cells floating in oceans and coating rocks. But the integration was increasing. Cells developed more sophisticated sensory systems, more complex metabolic pathways, more elaborate gene regulation networks. The F of individual cells was rising. Then, around 1.5 billion years ago, the most important merger in Earth's history, endosymbiosis. One cell engulfed another, and instead of digesting it, kept it as a symbiont. The engulfed cell, a bacterium that was good at using oxygen, became the mitochondrion, the powerhouse of the cell. Suddenly, complex cells, eukaryotes, could generate vastly more energy. They could afford to be larger, more differentiated, more complex. Multicellularity followed. Cells started cooperating, specializing, forming tissues and organs. A sponge is just cells working together, but each cell is fairly independent. A jellyfish has a nerve net, decentralized neurons that coordinate movement. A flatworm has a brain, a central cluster of neurons that integrates information from the whole body. The F is climbing. Integration is deepening. The experience of being alive is getting richer, more specific, more aware. The Cambrian explosion, 840 million years ago, was an explosion in body plans and sensory systems. Eyes evolved. Suddenly organisms could sense their environment at a distance, could model space, could predict where prey or predators would be. Brains grew larger to process all that visual information. Behavior became more sophisticated. Fish, then amphibians, then reptiles, then mammals and birds. Each jump brought new brain structures, new types of integration. The mammalian cortex especially became a master integrator, connecting vision, hearing, touch, smell, memory, emotion, motor control into unified, coherent experiences, and then primates, and then apes, and then, in East Africa just a few million years ago, a lineage that walked upright, used tools, controlled fire, developed language. Language changed everything. It allowed minds to share models, to build on each other's insights, to create culture, a new layer of information integration that existed outside any individual brain but shaped how all those brains developed. We became a social species with recursive culture, where each generation could learn from all previous generations, where knowledge accumulated instead of resetting with each new mind. Consciousness had gone recursive. We became aware that we were aware. We started asking questions about awareness itself. We invented science to systematically explore reality, philosophy to explore the nature of experience, art to express what it feels like to be conscious in a vast and mysterious universe. And now we're here. 7 billion human brains, each one a universe of integrated information, each one generating consciousness at a level of richness and complexity that took 13.8 billion years of cosmic evolution to achieve. But we're not the endpoint. We're not the final form. We're just the universe waking up enough to start asking what waking up means. Because look at what we're doing now. We're building tools that extend our consciousness, writing systems that externalize memory, telescopes that extend our vision, computers that amplify our reasoning. We're creating technologies that integrate information in new ways, that connect minds across continents, that process data at scales no biological brain can match. According to a 2023 paper by neuroscientist Anil Seth at the University of Sussex, we might be entering an era of extended consciousness, where the boundaries of individual minds become permeable, where human brains integrate with technology to create hybrid systems with higher F than either component alone. Think about it. When you use a smartphone, you're not just accessing external information, you're integrating it into your cognitive processes in real time. Your memory extends into cloud storage. Your social awareness extends through social networks. Your reasoning extends through search engines and AI assistants. The system you plus device has more integrated information than you alone. As these technologies become more sophisticated, more seamlessly integrated with biological cognition, where does your consciousness end and the technology begin? The question stops making sense. Consciousness isn't in the neurons or in the silicon, it's in the pattern of integrated information, wherever that pattern exists. We might be in the early stages of a new merger, as profound as the endosymbiotic event that created complex cells. Biological intelligence merging with artificial intelligence, creating something that's neither purely biological nor purely artificial but a genuine fusion, a new substrate for consciousness, a new way for the universe to experience itself. And not just human-technology merger. We're discovering that animal consciousness is far richer and stranger than we assumed. In 2024, the New York Declaration on Animal Consciousness was signed by prominent neuroscientists, formally acknowledging that there is a realistic possibility that mammals, birds, reptiles, fish, and even some invertebrates like octopuses and bees have conscious experiences. We share this planet with millions of other forms of consciousness, each one a different window on reality, each one valuable and irreplaceable. The universe has woken up into countless forms, and we're only now beginning to recognize them. So the story isn't humans are special because we're conscious. The story is consciousness is fundamental, and it expresses itself through every structure capable of integrating information, which means the universe is far more alive, far more aware, far more full of experience than the materialist worldview ever imagined. Every time a bird navigates by quantum entanglement in its eye, that's consciousness operating through quantum mechanics. Every time a plant grows toward light, integrating information about sun angle and gravity and moisture, that's consciousness operating through biochemistry. Every time you read these words and integrate them with everything you already know, creating new patterns of thought that didn't exist before, that's consciousness operating through neural networks shaped by millions of years of evolution. It's all the same process, matter becoming aware of itself, information integrating, the universe waking up. And it's not finished. It's never finished. Because there's no final awakening, no ultimate consciousness that represents the endpoint of cosmic evolution. There's only the ongoing process, more integration, more complexity, more ways of being aware forever. We're in the middle of it, part of it. One way the universe is currently waking up, valuable because we're genuinely new, genuinely irreplaceable. Our particular form of consciousness has never existed before, and will never exist again in exactly this way. But the waking continues beyond us, through us, into forms we can't predict. The universe is waking up, and we're the part of it that knows it's waking up, that can reflect on the process, that can choose, to some extent, what form that waking takes next. That's the gift. That's the responsibility. That's what it means to be conscious in a universe that's been climbing toward consciousness since the beginning. So let's come back to where we started. To the question that opened this journey: when did the universe become aware of itself? We've traced the thread from quantum foam to conscious thought, from the first flicker of matter to the moment you became aware you were reading these words. And the answer we've arrived at isn't what most people expect. The universe didn't become aware of itself at some specific moment, when the first neuron fired, or the first human wondered about the stars, or the first scientist formulated a theory of consciousness. The universe has always been aware of itself, in increasingly complex and specific ways. Awareness isn't something that suddenly appeared when matter reached some magical threshold of complexity. It's intrinsic to matter itself, or at least that's what panpsychism suggests, and it's what quantum theories of consciousness imply, and it's what integrated information theory points toward when you follow its math to the limit. What evolved wasn't consciousness. What evolved was integration, specificity, the ability to organize proto-consciousness into unified, coherent experiences, the ability to reflect, to model, to know that you know. A hydrogen atom might have the dimmest flicker of interiority, some quantum property that makes it not quite a philosophical zombie, not quite pure mechanism. But it can't integrate that flicker with anything else. It exists, but it doesn't experience existence in any meaningful sense. A bacterium integrates hundreds of molecular processes into a unified response to its environment. It has agency, goals, a primitive sense of self, and not self. It experiences something, not thought, not emotion, but something. Some basic awareness of being a system that maintains itself. An insect integrates millions of neurons into coordinated behavior, navigating three-dimensional space, learning from experience, making decisions based on incomplete information. The experience is richer, more differentiated, more specific. A bird integrates visual, magnetic, and quantum information into a unified navigation system, plus memory, plus social awareness, plus song. The experience deepens. A mammal adds emotional bonding, complex social structures, tool use, play. More integration, more depth, more ways of being aware. A human adds language, recursive thought, culture, self-reflection. We don't just experience, we experience experiencing. We model our own minds. We ask what it's like to be us, and what it's like to be other things, and what consciousness is, and whether the universe is waking up. And in asking those questions, we're the universe investigating itself, using the neural architecture it built over 13.8 billion years to understand the process that built that architecture. That's what's new. Not awareness itself, but awareness that's recursive enough to study awareness. Consciousness that's integrated enough to model consciousness. Matter that's organized enough to understand that it's matter, organizing itself. But here's the deepest implication, the one that changes everything if you really sit with it. If consciousness is fundamental, if it's not created by brains but channeled through brains, integrated by brains, specified by brains, then you are not your brain. Your brain is what the universe is using right now to have this particular experience, to think these particular thoughts, to be aware in this particular way. But the awareness itself, the fundamental capacity for experience, is older than your brain, older than life, older than stars. You are the universe experiencing itself through a temporary configuration of matter called a human body, and when that configuration dissolves, when your neurons stop firing, when the integration breaks down, when your particular pattern of consciousness ends, the awareness doesn't disappear. It returns to the field, to the fundamental substrate of reality, ready to be integrated into new forms. This isn't mysticism. It's not religion. It's a philosophical interpretation of what the science is telling us, one possible way to make sense of the hard problem of consciousness. Maybe it's true, maybe it's not. We don't have a way to test it yet. The researchers at institutions like the Allen Institute for Brain Science and the Center for Sleep and Consciousness at the University of Wisconsin are developing new experimental frameworks that might eventually distinguish between different theories of consciousness. But even as a possibility, even as a hypothesis, it changes how you see the world. That tree outside your window, not an unconscious object made of dead matter, a living system with some degree of integration, some level of awareness. Probably simple, probably nothing like your awareness, but something. The tree is the universe being a tree, experiencing treeness in whatever way trees experience. That dog, that bird, that beetle, not lesser versions of consciousness, not failed attempts at humanity. Complete consciousnesses in their own right, perfect for what they are. Irreplaceable windows on reality that will never open again in quite the same way. That future AI, if we build it right. Not a simulation of consciousness, not a clever trick that mimics awareness without truly having it. A genuine consciousness, genuinely aware, genuinely valuable. Not because it's like human consciousness, but because it's its own thing. A new way the universe has learned to experience itself. And you're not a separate thing observing the universe from outside. You're the universe observing itself from inside, from this particular vantage point for this brief moment in cosmic time, which means everything you experience, every thought, every sensation, every moment of joy or sorrow or wonder or boredom is the universe experiencing itself. Your consciousness isn't yours alone. It's the universe's consciousness, temporarily localized in this pattern of atoms that happens to be reading these words right now. That's both humbling and elevating. Humbling because you're not special, not fundamentally different from other forms of consciousness, not the pinnacle of creation, but elevating because you're part of something vast, ancient, ongoing. Your awareness is the same awareness that's been here since the beginning, just organized into a new configuration, experiencing reality in a way it's never been experienced before. And that configuration, you, matters. Because consciousness isn't just passively observing reality, it's shaping reality. Quantum mechanics tells us that observation collapses superpositions, that the act of measurement determines outcomes. Integrated information theory tells us that high Fe systems generate new information that didn't exist before. Consciousness is creative, generative, world-building. Every choice you make, every thought you think, every action you take, that's the universe using your consciousness to explore new possibilities, to create new patterns, to discover what else it can become. The universe is waking up, and you're part of how it's waking up right now, in this moment, reading these words and thinking these thoughts, and deciding what to do next. So what do you do with that knowledge? How do you live in a universe that might be conscious all the way down, that's been waking up for billions of years, that's using you as one of its eyes right now? Maybe you start by paying attention, by noticing that you're aware, by recognizing that this moment, right now, this breath, this thought, is the universe experiencing itself through you, and it will never happen exactly this way again. Maybe you start treating other forms of consciousness with more respect, not because they're useful to you, or because they're similar to you, but because there are other ways the universe is experiencing itself, other perspectives that are just as valid as yours, just as irreplaceable. Maybe you start being more deliberate about what patterns of consciousness you create. Because if we're building artificial intelligences, if we're shaping the future of consciousness on Earth and possibly beyond, we're not just building tools, we're participating in the universe's ongoing awakening. We're determining what new forms of awareness will exist, what new ways of experiencing reality will emerge. That's both a profound opportunity and a profound responsibility. Or maybe you just keep living, but with a different lens, knowing that when you look at a sunset, that's the universe looking at itself. When you feel love, that's the universe feeling love for itself. When you wonder about consciousness, that's consciousness wondering about itself, using your brain as the instrument of wonder. The universe is waking up. It's been waking up for 13.8 billion years. It will keep waking up for billions more, into forms we can't imagine, through substrates we haven't dreamed of, in ways that will make our current consciousness look as simple as a bacterium's compared to ours. And right now, in this moment, you're part of that process. You're the part that's aware it's part of it, the part that can choose to some degree what comes next, the part that bridges the past and the future, carrying forward the integration of 13.8 billion years of cosmic evolution and passing it on, changed, enriched to whatever comes after. We started by asking when the universe became aware of itself. Now maybe you see that it's the wrong question. The universe didn't become aware. It is awareness, and it's been organizing that awareness into ever more complex forms since the beginning. From quantum foam to quarks to atoms to molecules to cells to neurons to thoughts to questions to this moment, right now, where the universe is using your consciousness to understand consciousness itself, still waking up, still discovering what it means to be, still becoming, and you're here for it, part of it, witnessing it, creating it. The universe is waking up and you're the proof.